Hi everyone, it's Mr. Canfield. Who else is here?
No.
So, might get a little bit of interruption, but filming this at home, hope the lighting is acceptable. So, we're in our packet, we're going to be starting 7.4. This is specifically looking at right triangle similarity. So, it says, if you take a right triangle and drop an altitude from the right angle to the hypotenuse, the same thing happens every time. So here's our right triangle, and this is the altitude that I'm talking about. Remember that altitudes always they make a right angle with the side that they come to. So we have a right angle here and we have a right angle here. And if we take this and break it apart, you'll notice that we have A with this double angle here, D with that, and then there's this angle C. B has a single marking. And what we can notice is if we look at our big triangle here, in our big triangle there's a right angle, there's A with a double mark, and B with a single mark. So that means that that means that the double mark and the single mark together, they're gonna add up to 90 because that's 90. So that means that this is double mark and this is single mark, this is single mark, and that's double mark. So what's going to happen every single time is we're going to have a triangle where ABC, hold on, let me read. Because of the way the smaller triangles share angles with the larger, the big triangle is going to be proportional. So ABC, we went 2 lines, 1 line, right angle. So if I'm talking about this one, 2 lines, 1 line, right angle, I'm following the markings. So ACD, I could also say that ABC, which was 2 lines, 1 line, this was a single line, I should have drawn that in, right angle, 2 lines, 1 line, right angle, so that'll be CBD. And the order of these is always very, very important to make sure that we're talking about the right thing. So what about the 2 smaller triangles? Yeah, we could say that ACD is similar, triangle ACD is similar to triangle 2 lines, 1 line, right angle. 2 lines, so CBD. So the theorem for this is right here. The altitude of hypotenuse, if this situation happens, then it says CAB, the big one, is proportional to DAC and DCB. So let's see how this plays out then. So given that PQR is similar to QSR, what is QS? So we want to know what QS is. This is like our X. So I am going to kind of do what we did up here and just try to find out 2 similar triangles where one of them has X as a side and one of them has 2 sides that I know. So like QS, I want that. So I feel like I'm going to want PQS. And so if I call that my single line and my double line, PQS, that's going to be similar to, so then this is a single up here and a double up here, right? So this is always going to go like that and that are going to be the same, that and that are going to be the same. That's the way that these are going to work in these right triangles. I guess I could have marked it up here too. Like that's double, that's single. Okay. So PQS, so single, double, right. So single, double, right, QRS. And the reason I'm writing these is it's kind of like we did before where I'd like to draw myself a little mini triangle, PQS. And you're like, that's not right. It's okay, we don't need to worry about what the angles are. We're trying to find which side lengths belong together. And so I always follow this order. And now I look, well, P to Q is 20 and Q to S was X. So Q to R was 15 and R to S was 9. So, and like there, we know this bottom side is going to be X as well, but that's not important. What's important is now I have this situation where 20 is going to 15 and X is going to 9. And I do not have my calculator on me today. I am doing this at home, if you couldn't tell. Maeve's here. So What we can do is we can set up a proportion here, though. We can say 20 goes to 15, and that has to be the same as, so it goes 20 to 15, that's going to be the same as x going to 9. And then to do this, I'll do the butterfly. We'll cross multiply. So 9 times 20, we can use our calculator if we're not sure. That's 180. And 15 times x is 15x. And we'll divide both sides by 15. So that'll be 10, 12. Should be 12. So that is one way for us to kind of go through and do this. The other way to do it is to find that scale factor, right? You do 15 divided by 20, and then we can do 9 divided by, or sorry, I guess we're gonna have to go this way, aren't we? Well, you find the scale factor. So if we do 15 divided by 20, then we can say, well, 9 divided by x gives us our scale factor. It's a kind of a convoluted way. The real way that we would do this is we'd say 20 divided by 15, and then we could multiply it to find 9. The key thing is, like, if you're doing this, we see that 20 is bigger than 15. We wanna make sure that x is bigger than 9. So if we get a smaller number, we know we went the wrong direction. So let's find PS. PS is down, it's this piece here. Well, hey, I'm gonna continue on with what I was doing up here. These are so open-ended. This is a way to do it. It's not the only way. And there are shortcuts, and we'll learn the shortcuts, I think, later in this lesson, right? Right? I read ahead. No. All right, so we knew that QS was x, but we know x is 12 now, right? So if I'm trying to find PS, I could call that y if I want, right? I'm trying to find y right here. Well, I know that's 12. So I could say 20 goes to 15 as y goes to 12. Or any other, I could do 9 goes to 12 as 12 goes to y. There's so many different things, so many different ways we could set it up. Let's actually set that one up. Let's say 9 goes to 12 as 12 goes to y, because it doesn't matter. It doesn't matter as long as whatever one you start with it on the other one at the top. And whatever one you end with it at the top. So I picked the top right one here and the top right one here. Then the bottom one here and the bottom one here. So 12 times 12 is 144. 9 times y is 9y. You can put these on either side. It doesn't matter as long as you pair them correctly. So when I divide that by 9, divide that by 9, let's see. 9 times 12 is 108. And this is 36 more, so it's 4 more, so y is 16. If I'm getting these values right in my head, then I'm flexing. And if I'm getting them wrong, I'm sorry that I don't have my calculator on me. I'm using my phone, which I would normally use for my calculator, so. And I didn't think to bring a calculator home, but I did think to bring my tripod home. So I have my setup here. Maeve, what are you doing?
I'm painting.
Oh. What are you painting?
I'm painting the whole thing.
Oh, that's so cool. All right, let's keep going. Figured you could use a little painting break. This one says, find CD. We will need to be clever in our setup since we have so few given sides, and we will need to use a new solving method. Oh, I'm glad that the new solving method is hardly visible. So, if I say this is a single and that's a double, then remember that means that this over here is a single and that's a double, right? Those two, they flip-flop when they get there. So we have 5 is here. We want to know what CD is. We're going to call that X, and then this is 15. So that's just what the different sides say. And if I try to set this up using, this is actually probably the last time for these that I'm going to do this, because we're going to learn a shortcut that's going to save us some work on these kinds of questions. So I'll do A, D, C. So single, right angle, double. So ADC, then single is going to be C, right? Single, right angle, double, single, right angle, double. Okay. So A to D I don't know, but no, A to D is 5. I know A to D. And I want to know C to D. On this one, I know B to D is 15, and I want, oh no. We are trying to figure things out, but we have an unknown in both. So the trick is with this, and it always works like this on questions like this, where they give you like 2 pieces and they want to know the third side. I can say this to this, 5 to X. So if I did 5 goes to X, then I can do X goes to 15, right? So if this setup looks a little scary, that's okay. We're going to talk about it. But the key is that in the butterfly, the X is diagonal from itself when they only give us 2 pieces. So that's the key, really. Earlier in these questions, well, in this question, singular, we were given 3 values and we were trying to find a 4th value. In these, and this is definitely worth writing down. You know, if I was taking my notes, I'd write something along the lines of, only have 2 numbers, find the third with this. And it's the hypotenuse. I said X, but one of these might be X. The hypotenuse is always diagonal from itself in this one. So when we do that, we'll do the easy part first. 5 times 15, and I get 75. And X times X. Be careful. X times X is not 2X, because 2X is what you get with X plus X. X times X is something different. And so maybe I'll use something that we know. I know. Like let's just pick a random number. What's 4 times 4 gives you 16, which is called 4 squared. And X times X, by definition, gives us what's called X squared. So X squared equals 75. And you're going to study, this is called a quadratic when it has X squared. You might have seen these in Algebra 1. You're definitely going to see them in Algebra 2. This is like the start of Algebra 2 dealing with these. The situation that we're going to have is pretty straightforward. If I see X squared equals 75, we can get rid of a square by taking the square root because they're inverse operations. So we'll do that to both sides. Oh, it's so pretty. Are you going to get another piece of paper and paint some more?
Yeah.
Here, let's move it off to the side. Oh, I'm sorry. You didn't get to see.
Oh, this one is.
Isn't that nice? Oh, it is a little broken.
broken.
Well, you thought you were getting a math lesson. You're getting a painting lesson. So whenever we have X squared equals a number, take the square root of both sides. You get X on this side and you get the square root of that number, which square root of 75 is going to be somewhere between 8 and 9. So 8 point whatever your calculator says. There is a way to simplify these, and if you're going to be moving into honors next year, I would look up how to simplify radicals. Oh, did you press it? Oh, that's so cool. So this is the theorem right here. It's really hard to read, but it says the length of the altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of the segments of the hypotenuse. I'm glad it's so helpful. But if this is let's not use A, B, and C. This is X and this is Y, and this right here is our altitude, which maybe we can call Z here. They have it written down here, and it's a little bit hard to see, but it says AD to CD equals CD to BD. And the big deal is X goes over Z equals Z goes over the other number Y. This splits these two. So in this case, I have 9.6, 5.4. If I'm trying to find, I want to find RT. No, we're going to find UT first. Oh, that's this down here. We'll find UT later. So, or we'll find RT in that question later. Let's find UT right now. So we're gonna find UT. So all I have to do is say 9.6. We'll call that X goes to X, and X goes to 5.4. Cross multiply. 9.6 times 54. Oof, oof. All right, really paying for it now. All right, so that's 24, 0, 30, 48. Boy, this is not the ideal way to do this. And then we had 2 decimal places, so 51.84. So x squared is equal to 51.84, unless I made a silly mistake over here, which is possible because I'm kind of rushing. Because I don't know if you can hear my semi-crying son in the background. I want to make sure I can go support my wife. But we'll take the square root and we'll get whatever that is, 7 point whatever it is. 7 point and 8 point whatever are not acceptable in my tests. You have a calculator. I can help you with it in the future if you need it. I don't really care how you round as long as you round correctly, as long as the number that you end on is a proper way to cut off the decimal. So if this is 7 point whatever, well now it says let's find RT, and this is the same triangle down here. So I know this is 7 point whatever. Well, if I know that, and I want to find that, well now I can, excuse me, now I can try to make triangles like this up here. Like this now has reduced it to a problem that we've seen before. So like, and it's up to you how you approach it. I see this, like I see RUT. So if I want to do RUT, where use my right angle, I'll call this my single, so that's my double. No, yeah, that's my double. Single, double, single. So RU double. All right, so single right double. So then I'll do single right double on this, which was T, right was U next, and S was double. All right. It's worth noting, see how both of these triangles at the middle, they go T to U, and then when they come down here, they go to the other letter. When I did it up here, CD, that was that altitude, CD, and then it dropped down and it was opposite letters there. So I might have just saved myself some thinking in the future. Looks like that's always gonna work, but you know, this is me having taught this to you, figuring it out. If you figure out a shortcut for these, I would love to hear about it. So I know R to T is X, and I know R to U is 9.6. I know T to U is 7.x. I don't know what that is because I don't have my calculator, but it's okay. I know U to S is 5.4. Oh man, that's frustrating. This situation. Let me make sure I'm not missing something silly. Oh wait, I know U to T is 7.x. Okay, I didn't have the right pieces, I thought, but I forgot that I had that. So with that, oh no, it's still not going to help me, right? Because I don't know what TS is to tell me what RT is. So rats. I guess I'll have to do something else. Let me try doing the big triangle to one of my small triangles. So if I do, and this is possible, I could set it up and not have the pieces I miss, which this happens sometimes. So I do RST, from R to S, 9.6 and 5.4 together is what we'll get here. So let's see, that should be 15, right? So that's 15, and then RT is X. So all right. So I went single, right angle, double. So single, right angle double, single right angle double. No, I don't know enough information on those, right? Because if I go R to S to T, that gives me this, but I don't know that, and I don't know that, and I'm pretending that I don't know the Pythagorean theorem because I don't think I've taught that to you yet. I don't think our book has had it. If you know the Pythagorean theorem, I would just do Pythagorean theorem to get the third side. I'm gonna pretend I didn't say that though. So I think what I can do though is I can use this smaller triangle here. I think I can. So I did single, oh, I read this in the wrong order. S is the double, single, double, right angle, single, double, right angle, single, double, right angle. So yeah, I don't know that first side, but single, double, right angle. Let's see what happens with that. Single, double, right angle, RTU. I know R to T is X, T to U is 7 point whatever, and then U to R is 9.6. So now I have a situation where I have enough information. So, whoa, that's a pretty good one, Maeve. So I'm gonna do the, what if I write 15 goes to X is the same as X goes to 9.6, right? That to that, that to that. Oh, now I have a, this one was a little bit harder to see. And I don't think, for me personally, my brain does struggle a little bit to put the pieces together on this. This might have been super obvious to you from the outset. You know what? Look at this. Look at this. So it wasn't just the altitude that worked. I could do that same, oh, no, I couldn't because it's the full side. It's not the piece. Okay. Never mind. I didn't see, there's no trick there. So, and we'll do the same thing, right? We'll get X squared is equal to whatever 15 times 9.6 is. I'm not going to waste your time with that. Whatever number this is. And then we'll take the square root of both sides. So we're almost done. The main idea that you need to get with these is being able to get this middle piece, because that's the new piece today. Again, our book picks these numbers. So I could say, if we're trying to find ML, let's just say we're trying to find ML, we'll call that X. We'll say 4 over X is equal to X over 20. So it does always work like this as long as we have a right triangle with the altitude dropped. It has to be that special situation, and then we can do this trick. So I'll get X squared is equal to 80, and when I take the square root of both sides, we'll get X is about 9. It's gonna be like probably 8.9. And there is one more detail that I've left out with this, solving these, that you're going to learn more about in Algebra 2 if you did not learn about it in Algebra 1. There is another number that works for this. And I'm going to, I'll just talk about it now. Not only does 8.9 or whatever the decimal is that works to get 80, like whatever decimal times itself equals 80, 8 point whatever. The thing is, negative 8 point whatever will also get you that number. Every number actually has 2 square roots. And when you get into negatives, it gets a little fishy. But there are actually 2 square roots. But I've been leaving this out because we're talking about the lengths of sides, and you can't have a side length that's negative 8.9. So that's why we leave it out. We don't even need to think about it or worry about it. Okay. So let's say we're trying to find CD in this one. Literally, if we have this set up, we say 36 over X is equal to X over 64. We can cross multiply. I haven't done the butterfly for you at all today. All right, hopefully that helps a little bit. Hopefully you're not as sad now about these problems. So 36 times 64 is, I don't know. X squared is equal to that. And we'll take square root of both sides. You've got a calculator. You have a brain. So x is going to be approximately a number. Smiley face. It's going to be a number, yeah. What number should it be?
It should be a big number.
A big number. Oh, okay. So this kind of leads us into the next. No, wait, no. Yeah, we have one of those here. So let's look at this real quick. Zhang is constructing a 4-foot high loading ramp. The length of the back of the base must be 12.8 feet. The length of the back of the base. How long must the entire base be? Oh, base, back. So this is 12.8. So how long will the ramp be? And so this is the ramp here. Okay. So in case you're not seeing it, we have parallel lines inside a triangle. This is not an altitude, so
What's that?
this is not going to be. This is not going to be. What are you saying? I don't know what she's saying. So we want to find this, but it's not this situation, so I can't do the fun thing. Oh, he's saying it's 4 feet high. Wait, isn't that 4 feet high? You know what? Don't worry. Don't worry about this. Okay. So here's your assignment. Work on this thing. Figure stuff out. Some of these are gonna be very straightforward, just following the special move. Other things are gonna be a little bit trickier. So like this one says, how tall is the building? There is a split here. And my hint to you is you don't know how long either side is here. You just know that together they are 200. So this one's gonna be a little tricky. And then try to write the 3 triangles represented here similarly. This one says these triangles are similar, so now we find x, and then are these triangles similar? How do we know? So this once we get back to these are kind of review from stuff we were doing. So if there are no directions, just solve for x. This is your assignment today. And yeah, I'll see you next time. Bye.